Hello, good morning. There seem to be some small problems with the beamer. Okay, is everybody here? Okay, welcome to Weird Programming 2. I'm surprised to see so much people who want a headache in the early morning. This speech is the successor of last year's Weird Programming, which was repeated yesterday because of the high demand. Myself, I'm Markus Schaber. I studied computer science in Ulm, and there I got contact to the Chaos Computer Club. I'm no native speaker, so please be forgiving. Maybe this speech is an example for weird English, but if you don't understand me, please ask and I will try my very best. This speech is online. You can read the web address. The whole material is online. If you grabbed it 2 days ago, then it's worth a look for the update. I added a special surprise at the end of the slides that was not included in the old version. Today I will talk a little bit about the International Obfuscated C Coding Contest. Last year I could only tell about the results of 2001. Now I can present the results of 2004. Something about compact coding, some strange programming languages, some abused configuration files, core wars, a rather hackish discipline, demo coding, but only a short view, some weird production code for those who had the quartet last evening, as yesterday with Felix von Leitner and co. I have some other weird examples and a special little surprise. The International Obfuscated C Coding Contest, where they have some weird timings because the 2001 contest had some delays until 2002, and the contest planned for 2003 actually started 2004, and now the winners are available, and there are some very interesting examples. The best of show entry, you can see that source here. Actually 165 lines. It looks like rather usual uncommented C code, some funny defines, interesting makefile. Who can guess what it is? No, it's not from the cryptophone, it's not from Microsoft. In Microsoft you would use about 50 million lines for the same functionality. It's an operating system, multitasking, including a VI, including a graphical user interface and a shell. You use the same C file that is used with different options from the makefile, different defines. The first compile gives the operating system kernel. The second compile gives the shell. The third one gives the text viewer. Then they use tar and pack all those executables they compiled and the source code itself, so you have some to view, into a tar file, because tar is the native ramdisk format of this microkernel. And then you can use the kernel image and the tar file as ramdisk and say Lilo or grub or your favorite bootloader to boot this like a Linux kernel, and you get this operating system. And this is why I said that Microsoft would use about 50 million lines of code for the same functionality. Another sportive discipline is compact C coding, using or creating the shortest source code that follows the rules and implements a problem or the solution for a problem. There's currently a contest running on this Congress. It's still open until tomorrow, 8 o'clock in the morning. In the lightning talks at 11 o'clock, there will be the winner's presentation. We actually had some very interesting submissions up to now. If you want to try it yourself, try to get below 300 bytes, then it gets interesting. That's where the current submitters are. We had some very interesting and creative submissions. One submitted a program that was about 150 bytes long, but he used a special build script that had about 600 bytes of preprocessor defines. So, well, we just decided to count those 600 bytes together, and then he has the longest submission so far, and not the shortest one. But maybe he gets a special prize for this idea. The contest rules are on the web server. You can see the URL. So if you want to try it yourself, please don't hesitate to submit your solutions. The last year's contest was won by Holger Kuhn. The problem was to convert a number between different bases. You had input numbers in base 23 and had to convert them in the base 11 and use the blank as the 11th digit. The winning entry had 401 characters, and I think most of you would not guess what it does. Afterwards, there was still some hackery going on, and the shortest solution so far had 204 chars. It's below. Now another prize draw. Who can tell me what this is? Besides the author, maybe he's present. It's for the gamers. It's a working Tetris. If you don't believe it, this is the source. If you remember from before, you can see it's actually the same source. So you can compare. Now let's compile. There's some warning, but okay. I can actually play. Yes. Okay. Good. So I don't know why most current games come with a set of 3 or 4 DVDs packed together. There's no need for a funny game to need so much space. Okay, now let's quit it. Good. The next discipline I want to tell you something are the funny programming languages. We had some very interesting examples last year. I got some submissions from people who heard my speech last year and said, I have this and I have that. And I got some of them. One of them is RepSub, repeated substitutions. It's a language that is completely based on pattern matching and text substitution. So it's basically a search and replace. You have a set of replacement rules, and this is a Turing complete language. It is also a democratic language because all statements and memory cells have equal rights and can be executed at the same time. When you have 20 matches for 20 different rules at the same time, all of them can be performed in parallel. and there's no code hierarchy, no modules and classes and objects and subclasses and so on. It's for pure Democrats. The advantage, it uses less symbols compared to brainfuck. If you think that brainfuck, which uses 8 symbols, has the minimum set, then you can see here it gets with less reserved symbols. It is simpler than Forth. We had a talk about Forth yesterday, I think. Then it is more elegant than intercal. You know the language that uses come from as a substitution for goto, because goto produces unreadable code. And the intercal used come from, and repsub is even more elegant than this. And it is potentially more cryptic than C. It's at least what the author says. This language is proven to be Turing complete. It was a direct submission by the author, Marko Haška. Thanks. Are you here? Yeah, okay, back there. He told me that it is in production use at a big German company that produces light bulbs, but I should not tell you the name. Well, there are not so much big German companies producing light bulbs. Okay, there is no homepage for this project, but he allowed me to put the reference implementation and the specification on my speeches page, so you can grab it from there. The only problem is that you currently need MATLAB for it. Maybe someone can implement a free software alternative so we don't need proprietary software to profit from this great language. I can even show you the source, because this is the source for the interpreter. And well, I think it speaks for itself. Oh, there's actually some code there. Okay. And these are some example codes. The first is hello world. This is very readable. The underscore and minus are an escaping for the, no, well, at least the underscore is escaping for the blank. Below there is a small Turing machine. If you know Turing machines, you have a tape with binary symbols, and you have a cursor. The cursor here is represented by the word start. And below you have the transition rules. The word that you have as cursor symbolizes in which state we are. So we have the states start, 0, Z1, Z2, and Z3. And we use simple search and replace rules that match where the cursor is. The cursor always uses a symbol different from 0 and 1 to be distinguished from the tape content. And then you can match the cursor and what's on the left and right of it and replace it with something new. And so every Turing machine can be translated one-to-one in a repsub program. But you have one advantage. You can make something like thread fork, because when you write a replacement rule that produces 2 new cursors, then you have a multitasking Turing machine. The next language that was submitted by last year attendance is ARC. It's a 2-dimensional micro machine that has some similarities to Bifunge, the multidimensional language I told you last year about. It has an unlimited stack, and it is highly optimized for programmers that use text terminals. Most original text terminals can be switched in some high-resolution mode that provides 80 to 43 columns. So if 2 columns are reserved for window title and the command line of your favorite editor or something, then you still have 80 to 40 columns left for the current program. And so this is the maximum size for an ARC program. So you don't need to scroll. It's licensed under GPL, so it's completely free software. Everyone can use it and take benefit of it. There's a complete toolchain, there's an interpreter in C, there's a debugger based on Perl, there's an Emacs mode including debugger, and for Vim there is an editing mode. And maybe the name of this language comes from the error messages. Whenever the interpreter encounters an error, the messages begin with ARC. Not correct? Could you use, well, it's just, could you use the microphone, please? Yeah.
It's to improve simplicity of a programming language. The only error message with interpreter emits is ARC. So there are no more information which properly could confuse the programmer.
Okay. Yes. Simplicity first, one of the main principles of advanced programming. Here you see 2 example sources that come from the ARC distribution. The first one is a hello world. Should be no great surprise. The second one is actually usable. It's a ROT13 rotation implementation for this cryptological algorithm. It's highly used algorithm, very secure, and this is a very good implementation. Yesterday we had a talk about elliptic curves and they had too much mathematics. It's too complicated to implement it correctly, so use the simple algorithms that work since 30 or 40 years and have never seen any surprising security holes. This is another example, 99 bottles of beer. That was one of the disciplines I showed you last year. There is an extended version called ARC with a double A at the beginning. And there they dropped the limit of 40 lines for the length of the code. So self-modifying programs can grow as far as they want. And this language is believed to be Turing complete. We don't have a proof yet. The first one to prove this, and with a proof that convinces me to be correct, will get a pizza from me. So feel free. If you like theoretical informatics, feel free to prove this and get a pizza. While we are at Turing completeness, some people want to create universal machines as their applications and make everything configurable. And you have all freedom by configuring them. You can make lots of mistakes, and the result of those programs often is that the config files themselves are Turing complete. So you actually make the user write the program using the config file language, and your actual application is an interpreter for this config programming language, and the user has to write the application itself. Some programs even have to use a macro processor for writing the configs because nobody can do it itself. The fun factor is those systems can be abused to do something very different. A nice example is you can use the sendmail configuration to make a turtle race. There you see the SK art for the turtle, and if you start it, you have a nice turtle race and can give your bets who will win. I will not show it because I don't have sendmail as a MTA on my system. I use a usable MTA. Here you can see how you can make use of sendmail. Well, sendmail, it simply got old, and sometimes a complete rewrite is the best solution and much better than always trying to modify the old code. The next discipline I want to show you is core wars. There you have programs that fight against others. You had some nice example of core wars yesterday at 11 o'clock in the talk about breaking Windows firewalls. Alexander Bannauer was one of the speakers, if I remember correctly, and they showed that every Windows firewall, a personal firewall concept, that the concept itself is flawed and can't work, and as long as one program has the permission to get out of the machine, then every other program can use this to escape the machine. And this is where some kind of core wars, but other people make a sportive discipline. They use some micro machine, some virtual machine, and have a very limited assembly language in there, and they put their programs in and let them fight against each other. And the program that allocates the most memory and lives the longest, that gets the prize. So your targets are to knock out the enemies and survive as long as you can, just the same target that Trojan horses and viruses have on usual PCs. But if you use sportive core wars, you can be sure that you don't break any law, and you don't have to fix your neighbor's PC and remove the virus you wrote on yourself. The constraints that make it interesting are that you have a very simple assembler language, and you have only a few CPU cycles before the next one will kill you. And you have sometimes a size limit for the source files. I can give you some small live demo. There is a core wars distribution included in Debian, and I selected two programs that are from here. They have a document file where they have some interesting combinations, and I selected the program copy that has the strategy of copy itself into other places, and the other one is random that simply erases random memory cells. And if you start this, you can see one program is in blue and the other one is in green. And you can see the one copies itself at different locations. Let's just pause it. The light blue squares are the memory cells from the copy program when it replicates itself into other locations. And the green cells are those cells bombed, overwritten by the random program. There are a lot of more strategies you can use. We can try some other combination. Okay. So those two strategies, copy and random, prove to be rather equal in strength, because most time they are just, the copy is fast enough to have always enough copies to survive, and the random is shooting fast enough that there are always that he always destroys the copies from the random algorithm. So no, it doesn't accept it. Seems that it doesn't accept this setting. Wrong. Stop it. Okay. So we leave the copy in and replace the random one where is it? Search and destroy. Okay. So you see the copy one copies itself sometimes, and the search and destroy algorithm tries to destroy it. That's the yellow one. So here you can see search and destroy successfully killed the copy algorithm. Good. Just start another one. So you see that the copy algorithm has a limit of threads it actually uses, and the search and destroy uses those and then kills all at the same time. If you want to view the source, you can see here the source. It's just like a simplified assembly language. For every assembly programmer, it should be no problem. I don't know whether there's a GCC backend, so you can write C or C++ or whatever you like. Okay. The next discipline is demo coding. It had its root in the copy scene where the people who broke the copy protections wanted to get credits for their work. And so they usually took the crappy bootloaders or the place that the copy protection used and put their own introduction for the game into it. And so you had some limited resources, the boot block or something, and had to fit some nice graphic effects and possibly sound and load the program itself. And so there was some the people tried to get the best, and sometimes later writing those introduction and those demos became more important than cracking and copying the actual software. And so this scene got away, and now we have a whole demo coding scene where there are contests and you can submit your own versions. The usual try to get more out of the hardware than you believe, or to squeeze it into a very small file. So you have 3D shooters in 64 kilobyte binary, and when you run it, it unpacks about 20 megabyte on your hard disk and such things. You have amazing sound effects and mind-blowing graphics, especially on old hardware. If you know a C64 from Commodore or an Amiga or Atari ST, you have very limited resources, and you don't have a graphics processing unit that has more power than your CPU and can handle trillions of triangles in the second. So most of those contests either run on arbitrary hardware or impose arbitrary limits. to make it interesting, because if you don't have any limits, it's easy to create the best demo. You simply say, I need a 20 gigahertz 4068 processor machine with 2 terabytes of RAM, and then my demo will run fine. And so the people shall learn to create good code, to create efficient code, and to get the best out of the hardware. And one of the interesting disciplines that uses a very special artificial limit is the text mode demo contest. There was the contest number 7 running last month. They don't have yet shown the winners, but these are 2 example screenshots from the website. I cannot show you any live demo here because the last contests all used Windows as a platform, and I don't have Windows on my machine. And the current contest, who allows DOSBox as an alternative platform, has not published yet the winning entries. So I'm very sorry that I cannot show you anything, but you can do it yourself. In about half a month, I promise to show the winning entries. The next discipline is strange production code. You also had a speech about this last evening. It intended to focus on exceptionally good and bad code, whatever that means. And I try to focus on weird code, whatever that means. The first example is from Miko. It's a Corba implementation used by lots of open source projects. They have a state machine that has 3 states: completed yes, completed no, and completed maybe. And well, I'm not really sure. Maybe this makes some sense. It's just, it looks weird because if you don't know whether you are completed or not, maybe your design is flawed, or maybe Corba design is flawed and Miko just has to implement it this way. But if you see this the first time, you sit there and say, what? The next example is from the GNU compiler collection Makefile. It's about cleaning up. I know most hackers don't like to clean up, so I was very surprised to see about dozens of clean targets. There are, I think, about more than 60 different clean targets in the Makefile, and there are some targets like mostly clean and maybe mostly clean, and so I just think, oh, they don't know when it's clean, or maybe I don't know how they clean, and it's just like when we were young and our mother said, clean up, and you put everything under the bed, and then it's maybe mostly clean. But I still miss the still somehow dirty target that tells what's actually happening there. Then I found some very interesting example of code. It's about how to produce white space. There are some people that like to implement the wheel. I don't know the reasons. Maybe they distrust all existing solutions. There could be backdoors or anything, even when you use open source code. Maybe they think they can do everything better. But if you try to do everything yourself, you cannot get better, because doing everything is just too much work to do it better than a herd of people that tries to do it together. So the problem they tried to solve was to write XML output for them, configuration files. They knew that XML is cool and that you need XML if you want to be hip. Maybe you need XML to get funding for your project also, so there may be reasons to use XML. Maybe we want to tell our customers that we support the most modern XML technology and so on. So it could have marketing reasons. However, they needed to output XML and they don't use any existing solutions but write their own parser. And they want to produce pretty output with nice indentation and so on. And so to indent the lines, you need some white space. And so we have demand for some function or method or something that produces white space. And this is their solution from OpenMDX 1.4. It reminds me of some code that Fefe showed yesterday about the GCC lib with the ... It just looks something the same way, but it has another problem. It is more inefficient. First, in Java, this char array is created on every method invocation. So every method invocation creates a new char array instance. Then a new string instance is created. This string instance gets the char array, the start index, and the end index, or the count of characters. So this string then in its constructor creates a new own char array and copies the spaces from this array. And so you actually have a lot of waste of computing time to copy the things around and to create the array in the first time. And the much bigger problem is that you have an undocumented, limited size of how large you can indent your files. And if you try to indent for 300 bytes or so, maybe somebody wants to do that, then this blows away with an index out of bounds exception. And there is no documentation for this limit. The next code that's somehow strange-ish is from cookies setting. Some web application servers use cookies for session management. That is what they were initially thought for. They now are often abused for different things. So we use the cookie implementation for our Java app server, but we want to give the user an error message that he has to disable cookies. He has to enable cookies in order for this to work. We do, or they, the producers, do not trust on the error message that the app server produces. They wrote their own cookie testing routine. It works as follows. They set a cookie and they include some JavaScript in the login page that disables the login fields and displays a big error message when the JavaScript cannot read the cookie. Using JavaScript is no problem because JavaScript is necessary for the whole application. So if you have JavaScript disabled, so you get another error message. And the code they use to set this cookie is shown here. They send the cookie with an expiry time of 60 seconds, but the Java code sends an absolute expiry time. And we had the problem that one of our testbed clients had some clock drift, and the clock drifted more than 60 seconds. And this had the problem that the cookie always expired. So the server sent a cookie, and the browser said, okay, the cookie is too old, it's expired, and the JavaScript said, no, there is no cookie. The problem was that Mozilla and Opera, there it worked. It seems that they accept the cookie, but just don't send it back to the server. But the JavaScript can see the cookie. And the Internet Explorer handles this differently. He drops the cookie at arrival, and so we spent some time trying to debug our security options in the Internet Explorer because we thought there's some hidden feature that to enable these special cookies. Another problem is understanding object-oriented programming. Usually most OOP languages are based on classes and inheritance. all objects belong to classes, and you define some main classes, and then you can specialize them. Classes define common properties, all cars have something in common, and so on. I think most of you know this. If you have some object types that need slightly different behavior, but the main are equal, then you use subclassing. And this modification that the subclasses provide is transparent. It's transparent to the users. They don't know which actual subclass they have, and it's transparent to the superclass themselves that does not need to know anything about the modification needed for subclasses, because it simply calls this method, and the subclass has a different implementation for this method. There's an example from OpenMDX 1.4 that proves that at least one of those programmers did not fully understand this concept, because this is in the superclass, and they have this instance of and a subclass, 3 subclasses, though they put the special cases for the for the different subclasses as hard-coded code in the superclass. And that's just doing exactly the opposite thing of what object orientation was thought for. A next example of weird coding, it's more an accident. It was shortly talked about yesterday at 10 o'clock speech here. It's about a bank, and they have some information terminal for those who can't read German. This here is the bank service, and there it's please touch. So they want you to touch the screen to get some information. Here you might see some strange pixels, so you can zoom here. This is the corner. You see some pixels. I hope you can see it from the back. There are some strange pixels. The problem was actually that the front window that displayed those funny image and the menu and so on, it was too small and left some pixels free. And there was a bug in a start script that caused a shell window to keep open. And so if you click on these pixels, the shell window comes to the front. And this is a touch screen and displays a big logo, touch me. So you touch and you get the shell window. And on its OS2, this IBM operating system running there, where you basically are root when you have a command window. There is some not so good picture of the bug in the init script. I think it's no good photography, but the problem was in the batch file, they had as last line exit from 0, but they made brackets around the 0. So maybe that was a C programmer that tried to write a batch file, and this was the cause for the command line window to keep open. I heard that the bank actually was not very happy, or the security company that makes those info terminals was not very amused. Well, but we were very amused. The next one, the last strange production code I will present you, it's about making a make. A build system is basically a make. So you specify the rules how to produce your actual program. A friend of mine tried to port the subdb, aka maxdb, to Linux on PowerPC because he wanted to evaluate it. And to port this, first you have to port their build system. And he told me to show it here and make some demonstration because it is rather weird. He used some other word, but okay, I don't want to get sued. Well, but I did not get the build system to build. It didn't build itself. Configure bails out with a shell syntax error in the first line that is no comment. I tried it with bash and I tried it with ZSH. Both shells are the supported shells, and some lines below in the script they have a case where they do different things, whether it is bash or ZSH. So they support both not. But I have another interesting number, as you can see at the bottom. The build system itself is 2 megabytes bigger than the actual application that is built with the build system. And well, you can use make, you can use GNU or BSD make if you need some special features. You can add some shell scripts also, but why do you need 26 megabyte for a make? I just don't get it. And so there's no live demo for this. Okay. Some weird code can be found on the web. There are some collections, the daily what the fuck and the PHP what the fuck collections. If you need your daily dose, you can look there. None of my examples was from there, but they usually have equal or better quality than what I showed here. It's just sometimes 3 lines of code and you need half an hour to recover from this disastrous. It's just, how can you do that? Okay, so just for those people who need a daily dose. Maybe the wavelan works actually, so you can look now if you want, but okay. And now, as I promised, the special surprise at the end. Most of you know Brainfuck from last year, or from the talk from Clifford Wolf, was his name, I think, who tries to implement compilers for Brainfuck. It's this nice syntaxed Turing-complete language for the micro machines. Some may know Ook. It's a simplified Brainfuck for orangutans. Because orangutans cannot speak, they have some problems to say things like bracket and so on. And so Brainfuck was simplified to have only 3 easy symbols that can be pronounced by every orangutan. And there is another language that is called fuck. This is for people who like swearing. It's also like similar to Brainfuck, and I think those people like swearing because they program too much in Brainfuck. The homepage seems down, but basically it's some pattern matching to translate the symbols you type and to translate your swears and your bad words into an actually useful program. And if you know those 3 languages, then you know fuck Brainfuck. This is the code table. Actually, the first column shows you the operation in C-like notation. The second column shows you the Brainfuck expression. The sharp symbol here is an extension that some Brainfuck interpreters provide for debugging purposes. It prints the current position on tape and some bytes before and below it for debugging purposes, but it's not part of the Brainfuck standard. The orangutan language Ook also provides this debugging. You have 3 different symbols, point, question mark, and exclamation mark, and combination of 2 of them give you 9 possible commands. So it was easy to include this 9th command. Fuck, from what I saw from the docs that were available, it uses some pattern matching, so you can put arbitrary characters in between where are the stars. So here you can say fuck if you want, but you can say or something else, whatever you want. You have free imagination, and there is a special operation here to repeat the last command, put an exclamation mark behind. So that if you need the command really strong and you want to have it more than one time, put exclamation mark and it will be repeated. All three languages allow comments. And so there may be some different problems in interpretation. What is a comment in all three languages at the same time? But the reference implementation solved this problem. This is an example, quell text. As far as I remember, it was supposed to say hello world. It simply mixes those three languages. You can mix the symbols as you like. Yeah, well, just read it for yourself. You see some interesting interpretations of what you can write between the characters where the stars are. Okay. Maybe we have some contest for the funniest brainfuck extension next year or so. This is the end of my speech. The materials are online, as I said before. My question is whether you want a third sequel. If yes, was it a good idea to broaden the scope to strange production code, or should I drop this again? Send me feedback and suggestions. My email address is here, and convince the next year's Congress team to accept it if you like it. If you don't like it, write me that I should stop this bullshit, and I will be happy and have a lot less work. I hope my English was okay. If not, feel free to sponsor me some educational leave so I can improve my English trainings. Thanks for your